How much installation we have had in 2015-16 was close to 5-6 gigawatts. Now we are at 72-74 gigawatts. So it is like 10x. Then obviously there is a high demand of these things. Automatically there are many players which are in market and their supply is the geography of the plant. If it is close to sea, then obviously you will have high humidity. Your cloth based robots will not function. You have to go to the other option which is available is bristle based. So like we have the toothbrush, nylon based toothbrush. Similarly, some kind of polyethylene polymer is there, out of which they are making the brushes, which are very soft and have a certain thickness of 150 micron or 200 microns. There are different variants which are coming in the market. There are three coefficients in solar. Okay, solar cell especially. Alpha, beta, gamma, I call it. Thermal coefficient of voltage, thermal coefficient of current, thermal coefficient of power. Gamma is the thermal coefficient of power. If I reduce the temperature by 1 degree, how much is the power loss or the power gain? I was working with Tata Power Solar for the first 3 years after my master's in renewable energy and management. The performance evaluation of the assets, improvement of the assets in terms of energy output, and then baselining of the assets of different geography assets, and then merger acquisition, how you do the due diligence, how you evaluate the risk associated with the findings you have during the DDs or during the testings. All those kind of works I've done in past. Parallelly, I have some hands-on experience of working with the big data analytics. That is another thing I parallelly work on. And from last 4 years, close to 4 years now, I'm in Ampla Solar. It's a Petronas Group company where we are managing a lot of rooftop sites, some ground mount sites, and some open access utility projects. So I'm looking after the big assets, utility assets. Here I'm taking care of asset management as a manager, and I look after the performance and then technical side of the assets. I look after some part of cyber security, which is like upcoming field for the solar. Like there are new guidelines which distributed energy sector has to follow. CEA has issued guidelines and SECI is the nodal agency. They are trying to safeguard our projects from different cyber threats. Plus, merger acquisition is one of the area which is like my specializations. Mostly, I work around these areas.
We'll be starting off with the questions that the community has already asked in the past 1 month. From the time being, we have initiated this effort.
LVRT, HVRT is basically to safeguard the inverters from tripping in very short power disturbance events. Low voltage right through and high voltage right through guidelines are specified by CEA, like which kind of generator has to follow what kind of parameter. There is a certain time delay. Till that time delay, if the disturbance in automatically gets resolved, then you don't have to do anything. For the higher voltage events and for the lower voltage events, all the devices like in our appliances, there is a certain voltage range in which it operates on the best. Like in household, I think the 180 to 240 volts is the range, or 200 to 240 volts is the range. For different devices, it is different. So similarly, for the generating plants, that's a requirement, and we have to follow those guidelines. There are few customers which are connected at the MV level. We call it medium voltage, which is 1133 kV, and above 33, it will be high HV voltages. To those connections, basically, give those connections to high consumers, like high energy consumers, like factories, or if you have high consumption, and normally their internal infra is not working on 11 kV. They'll have step down transformer and a switchyard, which is giving that power to a switchgear system. And then from switchgear system, it is then spread out to different units of the plant, and it is scattered throughout there will be a grid of or the network of the electric distribution system. And if we are pumping the electricity, then we have to check with the discom at what voltages we are allowed to inject. At some places, we normally integrate our solar plants at the MV switchgear level, like 11 kV levels. We integrate that extension panel. It will have a breaker of solar, and that after the breaker, this power will be looped with the existing MV switchgear. And there are, in case of net metering, we can inject back to grid, but there are certain consumers which ask we only want for ourselves. We will be consuming all the energy which we are producing from our rooftop. In that case, that will be of the grid system, and it will be a captive kind of system. The energy we will be consuming by our factory devices and all. So in that case, we are not allowed to send it back to the grid. So there are certain kind of protections in place in our HVLV side that the energy should not go back to the grid. Since we are a consumer, we are not allowed to inject unless until we have the permission. That is how we normally connect. There are certain neutral system is provided to carry back the return path for the electricity. And in the star system, there is no neutral which is generated. I think in the star it is generated. In the delta, there is no neutral which is generated. So in the star, on the transformer side, some guidelines say that there should be a neutral throughout the grid side, but at some places they don't put the neutral throughout the infrastructure of the factory or the premises. That is about and grounding is some in some guidelines it is similar to neutral, but grounding function is mostly if there is some static charge or static residual currents which are on the body of any equipment, then we have to ground it to the earth. Like we don't want any electric hazards in our factory or in our premises. So it should be grounded. The current should flow to the ground. Thanks for the question. I think most of assets will have a Y connector, but we have different kind of assets where there is no Y connector. So directly strings are going to the inverter. And the purpose is mostly, as far as I know, is commercial. Wherever we can pull the electricity, and basically by putting the 30 modules in series, what we are doing is we are increasing the voltage of the system in series. Like if there is 40 volt modules, each module is generating at 40 volt, and then 30 modules are there, and 1200 volt will be the voltage difference between the positive, and we are increasing the voltage, but the current remains same since it's a series connection. And this string, basically string is by definition the term used when the modules are in series.
Okay.
And when we use the Y connector, what we do is 2 in 1 out connection we do. So we will have another string which is giving us 1 positive and 1 negative. Second string, 1 positive and 1 negative. What we'll do is we will parallelly add these strings, positive to positive, negative to negative, and then in parallel, since the voltage does not increase, and the current doubles. If 7 ampere, 10 ampere was coming, then it will double to 15 amps, 14 amps. What used to happen is, since every developer wants some kind of safety in the string side also. So earlier there was some MC4s which used to have fuses. Then one MC4, two MC, one fuse, two fuse. In those strings we have two fuse.
Okay.
We pull them and club at Y connector. So at the output, we increase the fuse rating. Earlier it was 7 amp, now 15 amps fuse if we put. So we have reduced by one. We have saved the cost of like by half directly.
Yeah.
Okay. And since two cables were running parallel till the SMB or the string inverter, now we will have only one cable which will be running.
Okay.
So this has come mostly from the on the optimization side of costing, and this is mostly that, nothing much technical, but saving cost. How earlier everything used to be copper, but now after the SMCV everything is aluminum. Only strings are having the copper based cables and the rest of the cables are aluminum based. But we have to think of like in terms of solution is, firstly we have to identify what is the geography of the plant. If it is close to sea, then obviously you will have high humidity. Your cloth-based robots will not function. You have to move to the other option which is available is bristle-based. So like we have the toothbrush, nylon-based toothbrush. Similarly, some kind of polyethylene, some polymer is there out of which they are making the brushes, which are very soft and have a certain thickness of 150 micron or 200 microns. There are different variants which are coming in the market. So, and so now if it is near sea, so obviously we have to go with the bristle. And then the Indian market has close to, I think, 30 odd players which are making products in India. Okay. So 30 robot manufacturers are there. I won't be able to name which are good, which are bad, but there are very good players which are improving or which are able to remove the soil of the plant fully. A lot of things go into it. There are certain times the budget constraints. Sometimes some developers want for OPEX models only. Some developers are with putting up their CapEx. ठीक है कि मैं अपना पैसा लगा के रोबोट खरीद लेता हूँ and then I put some labor or some skilled people to this task or unskilled people to this task of cleaning. And so both models of operation are there in the market. And then more than the purchasing, we want support because it should not happen like ki every second day it is breaking down. One motor is not functioning or some control card is failing. So we have to ask and take feedback from their previous customers. So whenever you are taking a call, ki I'm going ahead with this, please take at least two feedbacks from the market, how it is performing at your assets, how for how long you are using it. That kind of feedback is necessary. And then cost to value, we calculate like how much is the benefit coming out of the capex which we are putting. So these gave us all some idea how much numbers we want, which models we want. This is how we come to a conclusion.
Yeah, we've seen multiple factors are involved in.
Yeah, it's not a straight line answer.
Yeah.
And you have to do your own market survey about it, what all players are there. So this is like you want to buy a biscuit, which biscuit you want to enjoy, like or a bike.
Yeah.
You have all the options. So the market has opened up. There are many options out there. So everyone is promoting on LinkedIn, and you can search hashtag dry robots or wet robots. So there are options of wet robots also now.
Yeah.
So you put a water along with the robot.
Okay.
There is a pipeline which is sprinkling the water before the brush is going. So it improves the productivity of your cleaning process.
Okay.
Because otherwise one person is manually putting water, second is brushing it. It used to be manual 2, 3, 4 people job. But now, yeah, a lot of automation has come.
Yeah.
If I have to tell you how much solar potential or how much installation we have had in 2015-16 was close to 5-6 gigawatt. Now we are at 72-74 gigawatts operational. So it is like 10x. Then obviously there is a high demand of these things automatically, and there are many players which are in market and they are supplying. Some are out of Indian players, out of India players. They are manufacturing in India to, because the policies, Indian policies are such that if you import everything, it is very costly. You can't sell at the same price. You have to have few components which are manufacturing in India to have a competitive market.
How can I check the temperature of our solar plant, and what is the procedure? Please explain me what are the tools required.
I think if this you should answer. You're the best person to answer. I'll give it to you. You or someone, whoever is available, because you guys have been doing and you have some capability to answer this question.
I will take this up, Shivang. As Rajat sir has rightly mentioned, we've been doing that for a bit now. The right way to do this is that you can get a handheld thermography device. There are many sensors available in the market, which will allow you to check the temperature of your solar modules, check the temperature of your combiner boxes in a non-contact basis. You're not really touching them. You are safe distance from these devices. Again, if you're looking at identifying temperature lapses at scale, if you're looking at doing it for a couple of megawatts, then drones are the best way to do it. But if it's just a couple of devices that you want to monitor, you can look at any of the irradiant, the thermal sensors that are available. Fluke is one popular company that makes such sensors. Flare is another that makes such sensors, and they're easily available on Amazon as well.
This is one of the cameras offered by Fluke. What it does is like it has a kind of plane of array which it captures field of view. Field of view, there is a certain field of view. There are multiple, these are thermal photodiode sensors. These sense the temperature of the object which is in the front of it. We have, like during the corona times, we had seen these cameras at airport entry points. They used to see what infrared radiation my overhead is sending to the camera. So camera will be guessing the temperature of my skin. Yeah. This is how it's a passive technology. It does not harm your system. So there are different companies which are providing this. Says if you talk about most of the bigger projects in India, they are not in vicinity of cities since the land is not cheaper. We have to go to a far villages to get suitable land, and those are not affected by too much of dust. Like the aerosol dust is not there, which is emitted by our diesel vehicles or other emitting factors are there. And there is different kind of dust profile in different geographies. In the saline areas, you have a sticky kind of dust. There is black cotton, you have a different kind of dust. You have Rajasthan where it is loose, very loose soil on the modules. And then you have Delhi, NCR related areas where you have some smoky kind of dust, especially in winters, if I have to talk about. Yeah. Overall kind of dust is impacting your solar incoming radiation. If the solar radiation is not able to enter and reach the solar cell, which is the blue area below the glass, then it is not converting into electricity. We have to clean the modules to increase our electricity conversion. If we are able to, like the output by input, if input we are not getting proper, then automatically output is related to that. And in typical Indian context, we consider 2 to 3% soiling on average in a month. It's like a linear fashion. Daily there will be 0.2 to 0.2, 0.2, there will be a linear trend. And once you clean the solar module, it should come to zero. If we are cleaning with water or if there is, then ideally it should come to zero. Your planners should be clean automatically. and then again it start increasing if there is no rain or no cleaning. So it's like a zigzag trend.
Okay.
And there are some cement industry related projects where we use some kind of chemical this solutions which are environmentally dissolvable. They don't stay in the environment for long, and they are eco-friendly. We use those chemicals to clean up those panels when it is not going away with the normal water, the water which is of not so hard water, because then you'll have some white carbonate and sulfates and carbonates will be there on the glass. And these kind of methods we use. In the PVCist, 90.9%, I think something is wrong. There are two parameters, I'll just tell, I think 90% from where it is coming. So there is 50th percentile and the 90th percentile, which is mentioned in the PVCist. When we simulate, the PVCist give us 2-3 numbers. 50th percentile is something like at the peak of the normal distribution. 50% of the data is on the left, 50% is on the right. 50% is like 90% of the data is less than that. If I have to say like P50 number, probability of 50 is P is coming from probability distribution. So P50 number will tell ki this is the best I can give you, and P90 will say ki this is very least of aggressive number. I'll surely be able to reach this number. P90 is 90% of the time I'll be able to meet this number. P50 means 50% of the times I'll be meeting, 50% of the times I'll not be meeting.
Got it.
Means it is you can go here and here. I can win, I can lose with 50% of probability.
Got it.
It is like we consider P50 numbers since we have bigger projects. For the smaller projects, since there are not manned sites, you cannot control to that extent and you cannot be much confident that I'll be able to achieve P50. So sometimes we give P75. 75% of the times I'll be meeting the guarantee. 90% और भी उससे कम कर देते हैं अपनी मतलब साइड में खेलते हैं P90 में. P50 में बड़ा aggressive होता है. So this is P50, P90, P25 and PVCist. Or statistics also. We have improved a lot of productivity. What used to happen was like if one person is working for 8 hours, he really is working for only 4 hours because it's not physically possible to clean the modules throughout the day or in the early hours of the day and the late evening hours. It is benefit to the local people who are engaged in this module cleaning activity because they have to pick and place, or sometimes it is mostly automatic. Wherever it is retrofitting, which is done on the PV plant, there we have a pick and place type of robots. They are at their docking station. The labor will come and place it on the table. It will clean the table and eventually they have to pick from that and then move to the next table. The work has decreased and the effectiveness of cleaning has increased because it's a machine. You can predict the output. The human, it's very subjective. उसने खाना नहीं खाया हुआ तो means you can't expect him to be as efficient as the morning. जब वो मतलब it's a human nature. हमारे साथ भी होता है. Like I think we all go through the cyclic output कि कभी अच्छी है कभी बुरी है. So with machines it is like a constant. These two factors plus I think ROI, you get pretty good ROI. We are able to get the payback within 3-4 years for these products. There are, this is a good question. Boggled the mind of a lot of people and still technology and some sensors are coming, but it's not a easy job to do. But like there are satellites which are dedicatedly doing the forecasting for the solar radiation and solar spectrum which is falling on the earth. They are from the reflected radiation and which is going back to the satellite sensors, it is evaluating what has fallen on our maybe a different geography on different uh, zoom, or what should I say, pixel level. They are analyzing this data. We have ground-based sensors at each site which are measuring the radiation,
Okay.
which is like most close to what we are utilizing for our generation. We personally in our company, we have put a lot of sensors as per the IEC guidelines. I think 30-40 megawatt, we have to put one sensor. Our bigger projects, we have a lot of sensors which are the representative for those areas. So if you have 10 sensors and there is cloud on 5 sensors, on 5 there is no cloud, 5 blocks are generating as per that radiation and 5 blocks are generating as per that radiation. When I average out, in best case, these should balance out. The radiation and the energy should be of the same level. This is how we are managing, and this is most of the people in the industry, how they are doing. There are many kind of sensors, cloud sensors are there, which like the government or the SLDC has mandated to use. The cloud sensors are there, diffuse sensors are there, then direct sensors, direct radiation sensors are there. Those are installed. Currently, those are not being utilized that much, but in coming years, and in some companies, they have put a few CCTVs on the rooftops to analyze कि किस साइड से cloud आ रहा है, so that they can. But क्या होता है ना, cloud की height के कारण and cloud के size के कारण, cloud की direction के कारण आपका shadow पूरे fields के ऊपर affect होता है. It's not a what should I say, this science. Weather forecasting has been like a mysterious field, or what should I, unexplored field from long time, but with more and more satellite-based technologies and ground-based, so the different models are coming. So let us see how we'll be able to accurately forecast maybe to the next 15 half an hour level, next क्या होने वाला है. But as of now, the technologies are not, what should I say, they are yet to reach that level of improvement, as well as I think there are challenges, a lot of challenges, not easy. I might not be the best person to tell you about the wave trap, but I'll take up the question on the transmission. Okay. There are different ways of transmission. The power is getting transmitted through the cables, and there is one wire on the top of the towers. You may have seen sometimes OPGW, we call it. So it transmits the data from your plant substation to the grid substation. It is considered as one of the safest ways of communication because this cable terminates. It is not continuing in the grid. It terminates there. So it is like between 2 points only they are communicating through that cable on the top of tower.
Okay.
And sometimes we lay cables, these optical fiber cables are there. Sometimes RF towers are there. Through ISP only we are transferring the data to a SLDC, and with firewall and proper protection system. These are few systems which are being used in the current scenario in India. It's not a new area. There has been much of literature on the solar photovoltaic since the last 40 years. Like everything has been standardized. There are 3 coefficients in solar. Okay, solar cell especially. Alpha, beta, gamma, I call it. Okay, the thermal coefficient of voltage, thermal coefficient of current, thermal coefficient of power. Gamma is the thermal coefficient of power. If I reduce the temperature by 1 degree, how much is the power loss or the power gain? What the manufacturers give is the standard. I'll just cast a typical data sheet, just show what they mention, and then you'll be able to understand. Yes. So this is a typical Trina make module. The module manufacturer estimate the performance at STC. STC is 25 degree centigrade, and then NOCT is cell temperature at 1000 watt per meter square radiation, irradiance. If the irradiance, like here it is mentioned, 1000 watt per meter square, at this wattage or this radiation, how much will be the cell temperature? It will be close to 44. In some modules you will find 45, in some modules you will find 46 also. This is the normal operating cell temperature. What I was telling you was thermal coefficient of power, voltage and current. If I increase my temperature from 25 degrees centigrade to 26 degrees centigrade, this will be the additional thermal loss of my module. Like if I have a module of maybe this is 238 watt or 242 watt, 0.4% will be the power which will drop due to 1 degree extra temperature over 25 degree. So that is the ambient temperature. That is the lab temperature, 25 degree. So at 25 degree and 1000 watt per meter square radiation, the inner cell temperature will be 44. These are the conditions. This is how we can improve, or we can calculate how much is the thermal loss in my module. If I have an ambient temperature of 40 degree, so which is like 15 degree over and above the 25 degree rated temperature, so automatically my I think 15 चौक 60 हो गया ना, 6 degrees 6% will be lost. This 6% of my if I have 300 watt modules, then I think 18 watt or something will be lost in the excess thermal excess temperature, due to excess temperature. So this is how we compute this thermal loss for PV. In PV cells, the simulation is done on variable factors, and then they come up with a number that overall full year में आपका 8-9-10% क्या thermal loss होगा cyclic जो भी.
Perfect.
There is some guideline which would be there for the temperature like radiation part of things, but I'll tell you the basic one. अगर आपका 50 watt per meter square का sun irradiance आ रहा है, then 50 या 100 के अंदर आपका voltage पहुंच जाता है पूरे field VOC पे. The current is not there yet. For current you need more photons.
Okay.
But for voltage you don't need the radiation to be at the peak. आप सुबह सुबह भी अगर देखोगे किसी के घर में लगा हो and with proper clamps, don't do it with your normal multimeter 230 volt वाला. It should be rated for DC. Solar is DC and वो it's more dangerous or maybe equally dangerous to AC. उसके जितना ही डेंजरस है. तो रेडिएशन का हमारा वही कंसेप्ट रहता है कि द टेम्परेचर, एम्बिएंट टेम्परेचर एंड मॉड्यूल का टेम्परेचर, अगर वो डेल्टा बहुत ज़्यादा है तो कांच शैटर होने का, जैसे खाने गरम गरम कांच के बर्तन में कुछ ठंडा डाल दें वो चटक जाता है ना, तो सिमिलर थिंग कैन हैपन. मोस्टली डज नॉट हैपन इन सोलर बिकॉज इट्स ए टेम्पर्ड ग्लास. आई थिंक क्या बोलते हैं उसको, टेम्परिंग प्रोसेस करते हैं इसकी. उससे क्या होता है कि शॉक्स उतने इजीली उसको शटर नहीं करते हैं. बट येट दिस हैपन्स इन द सोडियम एंड दिस ग्लास, सोडा लाइम ग्लास जो अपना इंडिया का होता है. बट दैट हैपन्स. वी रेकमेंड कि 300-350 रेडिएशन, क्योंकि उसके बाद टेम्परेचर भी बढ़ेगा. सो यू शुड ट्राई टू क्लीन इट बिफोर 300 watt. And the pixels are very, I think the current high like 5-7 लाख का जो कैमरा आता है उसका 320x240 पिक्सल होता है. That is very less. क्योंकि उतना क्लियर क्रिस्प इमेज जो हमारे डिजिटल कैमरा बनाते हैं वो नहीं बनाते हैं, बिकॉज दे आर कैप्चरिंग डिफरेंट थिंग. थर्मल इमेजिंग, क्योंकि वो सिर्फ आप ना सिर्फ मेरा टेम्परेचर देख के मेरी इमेज बना रहा है. इट इज नॉट टेकिंग द क्या कहते हैं विजिबल स्पेक्ट्रम ऑफ द रेडिएशन. इट इज टेकिंग द इंफ्रारेड स्पेक्ट्रम विच इज माई बॉडी एमिटिंग. तो उसके बेसिस पे इट्स वेरी नॉट ए वेरी क्रिस्प एंड क्लियर इमेज. Yes, So basically, the testing is done in a lab at 25 only. And for Rajasthan, the temperature goes high as 50 degrees centigrade. So around 8 to 10% of the losses of the system are happening in Rajasthan due to thermal loss only. But in any mechanical or electrical system, the efficiency of the system is dependent on the efficiency of each system, step by step system. If I have a PV plant, the efficiency of PV module, then the efficiency of cable. If I multiply the efficiency of each and every system in the line, then I get the efficiency of the system. This is standard for all the technology. So the thermal loss or the thermal efficiency of the system decreases. It impacts the overall efficiency of the system. Basically, all are the irradiance factors. And GHI is horizontal. On the horizontal plane, whatever irradiance I'm getting in watt per meter square. And on a plane of array, I'm getting like my modules are mostly tilted towards south to get the radiation, good radiation in summer, in winter months when the sun is tilted towards the south. That is tilted radiation, GTI or POA, sometimes we call it. What else is there? Direct, and then tilted and horizontal, tilted, GHI, GTI, and
GII.
that is also inclined irradiance. I am talking about watt per meter square. If we accumulate the energies, this is power. Watt per meter square is power falling per meter square area. To compute into the kilowatt hour per meter square, you have to multiply it with the time interval. If you are measuring at 1 minute, you have to multiply it 1 minute and then divide by 60 to convert into hour, kilowatt hour, to convert into energy. You have to just multiply it, then you'll get the energy in kilowatt hour per meter square for the full day or the full year what we use. There are certain neutral system is provided to carry back the return path for the electricity. And in the star system, there is no neutral which is generated. I think in the star it is generated. In the delta, there is no neutral which is generated. So in the star, on the transformer side, some guidelines say that there should be a neutral throughout the grid side, but at some places they don't put the neutral throughout the infrastructure of the factory or the premises. That is about and grounding is some in some guidelines it is similar to neutral, but grounding function is mostly if there is some static charge or static residual currents which are on the body of any equipment, then we have to ground it to the earth. Like we don't want any electric hazards in our factory or in our premises. So it should be grounded. The current should flow to the ground.